Hello, students. This is Mansi Bhosle, your mentor for physics and maths. Today, we are going to understand one of the most beautiful phenomena that we see on a day-to-day basis, that is twinkling of stars. Stars are so beautiful, and when they twinkle, it's like magical. How does this magic happen, right? Why do the stars twinkle? What is the reason behind it? And how is it related to atmospheric refraction? Let's see. Now observe the screen very carefully. If you observe the screen, do you see little stars, small objects which are twinkling, right? Do all the stars twinkle at once? If you see, this one is twinkling one, then this is twinkling, then this is twinkling, then appears dim, again twinkles, appears dim, twinkles, appears dim, twinkle, appears dim, twinkle, right? All the stars are not twinkling at one time. Again, if they are twinkling once, they are not twinkling in the next moment. And are they stable? Just look at them. Just look at them. Are they stable at one place, or they are just jiggling here and there, here and there, here and there? The position of these stars is also not fixed, right? They always appear to us in a moving way. Yes or no? Can you observe this from the screen? Yes. Now, why is this happening? First of all, yes, stars are twinkling. One moment they are very bright, another moment where they're very dull, right? This is what we mean by twinkling. And if you see, if you look at the positions also are not stable. Let's see why. Now, as we had seen in the previous episode, the atmosphere above the earth is not same, right? We have different layers of atmosphere above the earth, and each layer of atmosphere varies in its density. It varies with time as well, because one time the atmosphere, there are very much temperature differences, temperature variations up in the atmosphere, right? Now, this is your star. Consider a light ray which is coming from the star, right? So a star has its own light, it produces its own light, it creates its own energy, right? So when light energy from star hits the earth, for example, consider this be any star which is far away from us. Now this is the way light from the star is reaching us. But when it reaches the earth's atmosphere, we know what is going to happen. It is going to get bended. Why? Because it is coming from vacuum to a optically denser medium. So at the point of incidence, what do? We draw a normal, and hence the light ray move towards normal. Again over here, it is again moving towards normal. Again over here, right? It is bending, and this way it is reaching us. So if you see in the entire process, when the light ray reaches us, does it reach in a straight way in this manner? So if it would have reached in a straight manner, the light rays from the star would have gone like this. But this doesn't happen. If this is the way light is coming, it bends and come. So this is the bending, and this is the way, right? Light rays is coming to us. So this is the bending happening. So this is because of atmospheric refraction. This we had studied in our last episode. This is because of atmospheric refraction, right? Now, okay, how is it related to twinkling? What is twinkling? First of all, I mean, just understand what you mean by a twinkling effect. When an object becomes bright at one moment, and at the same time, it becomes dim at another moment. Again, bright at one moment, dim at another moment. Bright at one moment, dim at another. So this dim, bright, dim, bright, dim phenomena, when we see to it continuously, this effect is called as a twinkling effect, right? Now, How is it now related to twinkling of stars? See now. So when density changes, as a result, sometimes more light reaches us and sometimes more light. So this is the person. So for example, just consider this is you, you are standing on the earth. Here we have our star. This is our star from where the light rays are coming. Initially, the light rays are straight. As soon as it enters the Earth's atmosphere and the different layers, it starts bending. Right? Now, as the density changes with time, when the density is very high, less amount of light reaches us. When the density becomes low, more amount of light reaches us. So every moment, each and every moment, the density is changing. So each and every moment, the amount of light reaching us also changes. So as the amount of light reaching us changes, at one moment, that star may appear very bright to us. At that time, the density of the atmosphere is less and we are getting more amount of light. At in the next moment itself, the star would appear very dim. So that means density of the atmosphere has increased, less amount of light is reaching us, and now it is appearing dim to us. Right? This is how stars twinkle. This is how the twinkling of stars is there, and we see the stars twinkling. Okay, the phenomena of hope you have understood. Right? Now, one more thing is there: apparent position of the star. The position of the star which we see is not the actual position. Okay, it is the apparent position of the star, because if you observe, this is the earth. Okay, this is the earth. Consider this, you are there. Now, for example, my star is over here, right? This is my star. This is the earth's atmosphere, from where the atmosphere of the earth is starting, right? So ray from light, ray is this. Okay, but is it coming in the same way? No, it is bending and reaching us. So if you consider the actual path ray, it is bending and reaching you, but human eye cannot see light as bended. Okay, we cannot perceive that, oh, okay, the light ray is bended and come of our way along to us. We will observe this bended light ray in a straight line like this. We will always observe the bended light ray in a straight way, right? So this is the way we observe the light. So in this way, we will see the star at this position. Okay, so this is called as the apparent position of the star. Okay, this is not the real position. Again, just to give you one quick recap, this is the earth. Okay, this is the earth, this is the star up in the atmosphere, up in the space. This is where the atmosphere of the earth is starting. Okay, rays from the is like this, and now when the atmosphere starts, they are bending and reaching you. Okay, so as they bend, you are standing over here. As they bend, the light rays are bending and coming to us, but do we perceive it as bended light? No, we always just perceive it as a straight line. So when we perceive it, we perceive the star to be here. So this is what we see. This is the apparent position. Okay, it is not the real position. This is the apparent position of star, and this is the real position of star. So the real position will always be at a place little down from the apparent position which we are seeing. So in this way, each and every celestial body which we see in the sky are all the images. So everything we see is false. They are just images. The real objects are actually at a distance little bit below the apparent position. Okay, so this is my real star, but I cannot see the real star. I can only see the apparent position of the star. Why? Because light rays are coming in a bended form. We cannot see the bended light. We will always perceive. So when this light ray reaches us, we will always perceive it in a straight line, and we will see the star to be here. So this is the way your apparent position and real position of the star will be there. Understood? So now let us see if a question comes, what are points you need to include? So twinkling of stars and its apparent position. So first time you need to start with is twinkling of star. Why is twinkling effect is there when light is coming from stars? It is due to the atmospheric refraction of the starlight, because when it appears the Earth's atmosphere, light refracts. Stars appears only as point sources of light, point size in the sky, because they are very far away from us. So we will actually see only one ray of light which is reaching us. The starlight on entering the Earth atmosphere, what it will go? It will undergo refraction continuously before reaching the Earth, and due to slowly changing refractive index of the various layers of the atmosphere. The apparent position of the star is not fixed. That is why in that first video which I showed you, were the stars stable? Were the twinkling stars stable at one point? No, they were continuously moving. Like if it is over here, it was continuously moving in the space here, 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 here. Again, bright, dim, bright, dim, bright, dim. So the position also keeps varying slightly. Since the why is the position also varying? Because the physical conditions of the Earth's atmosphere are also continuously changing. There are temperature variations above. When the temperature increases, density decreases, more light reaches us. Temperature decreases, density will increase, less light reaches us. Right? So the starlight flux, that means what is flux? Flux is the amount of light rays reaching us. Entering the eye fluctuates with time. We are not able to see the same amount of light is not reaching us all the time. It varies, it fluctuates with time. Due to this, the star appears brighter and sometimes fainter. The fluctuating apparent position of the star gives rise to the twinkling effect of star to the eyes. The stars nearest to the horizon appears to twinkle more than the stars that are up above the head. This is because, so for example, what is horizon? This is Earth. You are standing over here, the straight way. This is called as the horizon, right? So now the stars which are at the horizon, they appear more twinkling as compared to the stars which are up above you, because what happens from above, the light rays are reaching you in a straight perpendicular normal manner, and we know whenever light rays reach in a perpendicular manner, do they get refracted? No, they will directly reach you. So this is because the starlight near the horizon has to travel more distance in the air, and the stars just above your head has to travel less distance. So the scientific name of this, the twinkling effect, has been given a scientific name that is called as the stellar scintillation. Stellar scintillation. Okay, so these are the points which you have to write if a 2 mark or a 3 mark question comes on twinkling of why do stars twinkle and about the apparent position of the stars. You can also supplement your answer with the diagram. Okay. Now, next we are going to study, just give it a thought. Okay, if stars are twinkling, why aren't the planets twinkling? Why? Have you ever thought? Yes, planets should also twinkle, but why aren't they twinkling? Stay tuned for it. This we are going to deal with in our next episode. Hope you enjoyed. Go through the videos nicely, each and every point. Comment on the videos, comment all the doubts. If you are not understanding anything, I'll get back to you as soon as possible. Thank you. Bye bye. Have a nice day.